So welcome back. Hopefully you had the chance to refill your coffee cups, and now we're going to move on to the Q&A session. Hopefully before the event you had the chance to see some of the fantastic videos created by our various EASA experts. And we got some initial questions that came in from those videos. If you didn't get the chance to see those already, you can go to the EASA YouTube channel and check them out there. Similarly, afterwards, you will also be able to see this symposium as well. So make sure to check that out. So we're going to go for the first question to my colleague Volker. Volker, are you there?
Excellent. Yes, I'm here.
Fantastic. So for the first question we have from Andrea, he's talking about energy reserve and saying energy reserve is strictly linked to safety, but can the pilot fully rely on the energy reserve indication? Or what are the EASA requirements for energy reserve calculation? And the energy reserve is then introduced into flight time. The power for takeoff, landing and hovering is known to be 2 to 3 times than the cruise power requirements. So the energy reserve can be depleted quite quickly. If, for example, we have a long landing phase, perhaps due to a rejected landing approach, we have a huge energy reserve, then will impact heavily on the weight. And so eVTOL performance and range. What's EASA's view on these topics, Volker? Thanks.
So those are very good points. Also, we consider these very crucial for the actual flight performance and safe operations. So right now, the means of compliance for the certification as well as for the operational requirements will have to go hand in hand. Right now, we have 2 subgroups in the workgroup 112 of EuroKE established, in which they are dealing on one hand with the battery itself, with the energy data, something like state of charge, state of health, as well as another group dealing with the depiction of those information to the pilot in an appropriate manner. So considering the nonlinear consumption, the concepts for the substantiation of the data, as well as a suitable way to show them to the pilot for flight planning and the in-flight checking are really essential and challenging. So we haven't put any definite numbers right now, but these elements will then have to find their way into the operational aspects with the accepted means of compliance and guidance material. For example, as part of the rulemaking tasks 0 to 30 for the urban air mobility operational requirements, as an example. So the steps are being made, but the effort is still continuing, and we hope to find the adequate solution for the kind of operations.
Thank you.
I hope this helps.
Thanks. And we have a follow-up question then from Alex, who asks, he says, adapting reserves for a particular aircraft, an operation type, obviously is a well-established method in commercial air transport, such as the use of statistical contingency fuel, for example. Now, however, that requires, relies on big data from past operations. But his question is, will the same type of data, but generated from Monte Carlo simulations, be a way of implementing this type of statistical outlook for energy reserves?
Again, another good point. So I would assume that right now the statistical data based on simulation would not be a good starting point. So we should rely on real collection of statistical data during the operation. While for the initial phase, we will have to rely on the data collected during the certification activities to develop respective energy consumption information and on those data to develop the operational aspects. That should then help to take further the data collection, based on which then further enhancements in the use of statistical data can be made.
Fantastic, thanks. And then there's another question from Christian, who asks, will there be an update to the fuel planning rules for conventional CAT operations with manned aircraft in accordance with the planning rules for VTOLs? So, for example, a more performance-based approach. He says this seems quite important to keep up the competitiveness and not to withdraw the conventional operations from the market kind of by intention, if that makes sense.
Well, the operational rules are currently being updated. You will find the EASA opinion 02 of 2020, published in October, which already brings up a couple of new elements and also implements the wording of fuel/energy as a baseline definition of the respective parameters. On one hand for commercial air transport, but also for other domains. And that should implement aspects that we are now making use of when providing the draft proposals for the Part UAM.
Fantastic, thanks. And a final question for you from Rebecca is, she asks, is the application of this energy reserve methodology being considered for applications outside SC VTOL rules and Part UAM? So, for example, an electric propulsion energy storage system to replace traditional propulsion and fuel systems for craft that might otherwise be certified under Parts 23, 25, 27 and 29.
So it's more on the operational side where we already have taken aspects of that on board. As said in the 02/2020 opinion, these elements have been considered so that we can provide for commercial air transport and for other operations the fuel/energy policies and schemes to be more tailored to the actual needs. That's in the frame of the rulemaking tasks 0573 that with this opinion comes to a positive step. Now, as regards the technical side, we are implementing then on an as-need basis the relevant technical requirements when it comes to the use of electrical energy, since you know that we have certified an electric general aviation airplane just not too far ago. So similar steps are now being taken for the eVTOL, and by that we hope to cover the adequate steps.
Perfect. Thanks very much, Volker. I think hopefully everybody found those really informative and interesting. We're next to have a question more related to human factors from my colleague Mathilde. Mathilde, are you there?
Yeah. Hello, John.
Hi. So the first question is from Beatrix. She asks, will EASA offer trainings for applicants so that they can better understand the new task for human factors assessment? And is there any difference in this task between complex IFR certified dual engine rotorcraft and small non-complex VFR certified single engine rotorcraft? And then will this training also include the description on how to implement the early EASA involvement into the LOI concept, in which EASA experts then mainly check final decisions and final documents of the applicant? Thanks.
Yeah, thank you for your question. So as it was anticipated in the NPA 2019-11 implementing human factors requirements in rotorcraft products, EASA is considering organizing an information session after the publication of the decision related to this rulemaking task. The ultimate objective of this event will be to actually present the new CS provisions and provide clear indications and best practices on how to implement them during future certification projects. Such information session should take place during the Q2 or Q3 2021, and as soon as a date is fixed, it will be advertised through the EASA website and the advisory bodies of EASA. On your question about the existing differences in the application of this requirement between products, even though the general process required by AMC 27 and 29/1302 is the same on both cases, there is an existing proportionality as the applicant for complex IFR certified dual engine rotorcraft, as you mentioned, will need to follow the entire CS and AMC 29/1302. And on the other hand, the applicant for small non-complex VFR certified single engine rotorcraft will have actually the possibility to not prepare an HF specific test plan and also use single test and single crew when performing HF evaluations. A similar proportionality approach applies as well to major changes. In the end, regarding the possibility of having training specifically on how to implement the early EASA involvement into the LOI concept, there is no training plan on this specific topic But I guess we're taking this point for discussion in the development of the info session that will be launched next year. Also, I think it's important to mention that LOI does not involve necessarily an approach based on final check, but in contrary, the definition of LOI might actually bring the possibility for an early ESI involvement if it's deemed necessary. So the applicant is expected to actually perform a familiarization session at the beginning of the project in order for ESI to actually define their LOI. So I hope that I have answered your question.
Fantastic, thanks. I think that was really informative. And there's a further question then from Vladimir, who talks about that, obviously human factors are quoted as one of the main factors behind a majority of modern accidents these days. We see rotorcraft and aircraft developers striving to maximize automation of control and of different types of aircraft and helicopters. And then obviously these efforts then lead to further complications in terms of the automatic flight control systems, which then potentially increase the probability of failure. And then there's a further consequence that he considers that pilots focus then potentially less and less on controlling the aircraft or the helicopter, devoting more of their attention instead towards controlling the flight control computer rather than the aircraft, and the potential then loss of piloting skills. And I know that's a common source for discussion. Thus then pilots potentially lack the skills to perhaps step in and control the aircraft or the helicopter without the help of an autopilot if there's a situation where there's an emergency. And there are some examples, obviously, we know of where this is obvious during accident investigations, and he says that it's necessary to acknowledge the existence of a problem of ensuring the future flight safety through larger automations of controls, actually then decreasing the amount of practical training that pilots get during the course of their work on a daily basis, which, particularly in critical situations. And then kind of at the end of the key question of that is then, which solutions does EASA offer to solve these kinds of problems, Mathilde?
Thank you for the question. It is an interesting question with many different aspects. And I'll only focus in my answer on the human factors aspects. So first, as you mentioned in your question, reduction of human errors. I think it's important to mention that the reduction of human errors is not the only driver in the implementation of automation in the aircraft. For example, the increase in automation is also used to reduce crew workload, which can ultimately be used as a criteria to determine the minimum flight crew or to optimize the human machine performance. Automation can also relieve pilot from repetitive tasks. Also, following the other point raised in your question, it's important to make a clear distinction between the basic skills and the evolution of pilot tasks. There is still a need to promote basic skills, but we also need to accept that the current and future cockpits are actually changing the operation and tasks of the flight crew. With regards to the skills to step in and regain control, I think the most important aspect to be considered are actually related to the difficulties encountered while trying to understand the abnormal situations. This is typically the case for some recent accidents where it was observed that the crews were not able to actually build an accurate awareness of the situation related to system status and to properly diagnose abnormal situations and therefore to take the appropriate decisions. So instead of maybe focusing on basic airmanship issues, the focus should rather be made on the improvement of the human-machine interactions between the aircraft and the crew, as well as on the quality of this diagnosis that is made by the crew when dealing with those abnormal situations. So in addition, and to conclude, I think it's important to mention that the increase in automation does not lead to degradation of the level of safety, but it rather modifies the possible nature of the accidents and incidents. So we recognize that there are still margin for improvements, and these margins are and will be covered by the existing and future regulatory framework, including 1302 requirements and others.
Fantastic. Thanks for those insights, Matilda. That's really
Thank you.
informative and I'm sure help the audience. And perhaps, for another view on this question, we could turn to my colleague Guillaume. Guillaume, are you there? Fantastic. It's like the Eurovision Song Contest here. Guillaume, can you give your view on that, please?
Yes, sure. And actually, the question from Vladimir was posted in front of the video for the AI roadmap. So I wanted to bring in the perspective of this EASA AI roadmap in. And it's understandable because actually we all recognize that the use of AI and machine learning will bring some new and maybe more complex type of automation. The important thing to add is actually that the approach of the EASA AI roadmap is resolutely human-centric. And they are providing the human with the right level of information and control over the AI is a key factor to the safe usage of such AI-based systems. So in this respect, we are working closely together with our human factors colleagues like Mathilde that you could see just before. And I think it's a complementary work, or it's a teamwork actually to work on this aspect.
Fantastic. Thanks for that additional insight into that situation, that question. So we're going to move on to another subject now. We're going to talk about doors and canopies. We've got a question that I think is ideally addressed to my colleague Jonathan. Jonathan, are you there? Fantastic. Hi. So,
yes, hello, John. I'm here.
Fantastic. So we have a question from Charlie who asks, he said, can we please confirm that the definition for doors, canopies and exits includes all external openings such as baggage doors and service ports, and thus requires both a means of retaining the door closed in flight and an indication of the status on and adjacent to the door, as well as on the flight deck display? And if correct, does this still apply to those doors and canopies and exits, including such things as the baggage doors and the service panels, where it can be shown that no hazard exists should they open in flight?
Okay, thank you, John, and thank you to our colleagues in the New Zealand CAA who have posted these questions on these topics. And there's one or two points related to this that I'll try and do and cover all points. The first part is really defining what is a door. And we've tried to be quite specific about this because it's quite easy to think of a door in terms of either what a person passes through or, for example, what some baggage passes through. And in fact, the scope of doors in this context is wider than that. And it pertains to anything on the exterior of the vehicle that can be opened. And going to a kind of parallel question that we've received, that applies to something that opens into a baggage compartment or opens to access systems, as well as opens to allow ingress and egress to and from the vehicle. So first, a door is anything that can open. But there is another point that is in fact covered to an extent by the regulation itself and further in the MOC material, that the requirements we put on for retaining the door closed and indicating the status of the door, they pertain to doors which could be a hazard if they become unlatched in flight. So obviously for, say, passenger doors, the hazard is somebody falling through it. In the case of other doors, it can be, does the door stay attached to the vehicle? If it doesn't, how big is it? How heavy is it? Where does it go? What damage could it cause? In terms of an access panel, if, for example, that access panel was providing a cover to, say, safety critical avionics, well, if the door opens, then the avionics could be open to weather phenomena, which could cause their own damage and have their own effect associated with that. So there are a number of considerations for whether the door could be a hazard, if it becomes unlatched or open in flight. But it is only to those doors which could be a hazard that the MOC material is really applicable.
Fantastic. Thanks for that, Jonathan. Hopefully that answered the question and gave a good comprehensive overview of that situation. For the next question, we're going to turn to my colleague Anne. Anne, are you there? Fantastic.
I am there.
Hi. So the first question we have from Karim is, he talks about halon extinguishers, and he says, obviously halon usage in helicopters has been prohibited since December 2014 in the new design, in new designs. However, there's still no qualified agent by EASA to be able to replace halon, especially in DFZ, except in some heavy alternatives. Is there any ongoing study for alternative agents to certify for eVTOLs to replace halon by the agency?
So thanks for the question. That have two aspects. So the first is concerning the ongoing study. It is not an EASA task to perform study on a new fire extinguishing agent. And I should admit that for the time being, no applicant has applied to EASA for a new agent certification dedicated to eVTOL technology.
So then,
continuing with that, concerning the halon extinguishing agent, it has to be noted that this agent is dedicated to conventional fire, I should say, so fuel fire and some electrical cable, but not to a battery or an electrical motor. For the second part of the question, I should say that the EMC presentation is focused on the battery for propulsion as well as electrical motor for propulsion. So battery described in the presentation doesn't affect the current conventional VTOL rotorcraft designated fire zone. So in consequence, EASA doesn't see any contradiction.
Okay, fantastic, thanks. So then we have another question for you from Barbara, who asks, in the video that we did on fire protection in DFZ, it's explained that there's a reaction time of 5 minutes to identify, confirm, take decisions, and initiate fire procedures that is incompressible. Given the high importance placed on fire detection and mitigation in an electric aircraft and the corresponding multiple redundant sensors and flight planning, pilot training, that the mentioned 5-minute time for the described actions is considered a bit too long. Therefore, her question is about this incompressibility of the time period.
Yes, so thank you for the question. This question has been also discussed during the EuroCAE group. In fact, the reaction time of 5 minutes is something that is already existing in the current regulation 23, 25, 27, and 29. Yeah, it is requested by the fire resistant, and it covers reaction time of the system as a time to reach a certain temperature, voltage, to have the alarm trigger and transfer the gas message to the cockpit. It also covers the reaction time for the pilot to identify, confirm, and initiate the lecture or the procedure of an AFM or RFM. During that period of time, a certain number of equipment shall keep their full integrity, and this time shall not be compressed.
Okay, thank you. And a final question for you from Rebecca. She asks, is there an intention to include the not one fit for all MOCs for electric thrust propulsion units and batteries to aircraft certified under CS 23, 25, 27 and 29 in the future? Or does this refer solely to those vehicles covered under the SC VTOL and Part UAM?
So thanks for the question. In fact, the presentation made on PowerPoint was tailored for the eVTOL step 1, so full electrical. Currently, the demand from the industry at that moment is high for eVTOL vehicle. But for sure, the experience gain in the domain during the rule-making process and the certification phase of eVTOL will be reassessed for other projects if it is requested by the industry.
Fantastic. Thank you very much for that. And again, hopefully the people that asked the questions found those useful, and so did the rest of the audience. So for the next question, I'd like to turn to my colleague, Emily. Emily, are you there?
Yes, I'm here. Hello.
Hi, good to see you. So we have a question from Alex who asks, and I'll put the three parts together just to make things a bit easier. So we have, so with the aircraft that have a variable configuration power units, tilt rotor and tilt wings, etc., which have fixed stops in their TLU position range, will the TLU failure case only need to be demonstrated or analysed at the stop positions or also for the transit positions? And then he asks, if it's the latter, how many positions need to be considered? And then how would you tackle the system that do not have those position stops for the TLU?
So thank you for the question. As the lift thrust unit failure case should cover the most critical scenario, all the possible lift thrust unit positions should be considered. So the lift thrust unit positions during the transition phases should be taken into account, but these only need to be combined with feasible or relevant flight parameters for the transition phase. For example, if the transition is only possible or permitted at a certain range of airspeeds, only these speeds need to be assessed, combined with the lift thrust unit transition positions for the failure case. And the same is valid for systems that do not have position stops. All the lift thrust positions should be evaluated, associated with the appropriate flight phases, in order to cover the most critical lift thrust unit failure scenarios. So I hope that answers the question.
Fantastic. Thanks very much for that, Emily. And for the next question, if I could turn to my colleague Laurent, who I have a question from Yasin. Laurent, are you there? So I'll start going through the question. There we go. Fantastic. So the question from Yasin is, before the maiden flight preliminary flight acceptance test is generally performed for flight safety system integrity and structural development tests. Now, this test is included and explained in military JSSG and AMAC documents, and it's similar to the endurance test, but performed before the maiden flight. So the CS29 AMC or GM doesn't include a regulation like the PFAT. And he asks, is there a civilian regulation or guidance material to explain this, this preliminary flight acceptance test? So for helicopter projects, the PFAT or tie-down tests are done on complete configurations with the MOC6. And these tests can then be accepted on an identical configured Iron Bird or ground vehicle. Now, if the test is done on a flight test prototype, then damage may happen on the body structure. And if this damage then happens on the structure, can the test be considered to be compiled, as the parts in consideration are not affected, as the test could have been done on an Iron Bird and or with additional reinforcements. So for VTOL, is the damage on the structure acceptable during the test?
So thanks to address this interesting certification aspect. In fact, this question addresses the level of justification to be provided for first flight and the interpretation of a first result. But this is also a general issue for certification. What is the extent of tests to be performed for compliance demonstration? So we should first mention that there is no consideration in the VTOL requirement, or in the means of compliance on the extent of tests to be performed for first flight. However, considering past CS27 or 29 certification experience, at least 2 structural conditions should be demonstrated before first flight. We would like to say limit load capability is one criteria, and the demonstration of a good behavior of a transmission system to be addressed through functional and endurance tests. So in this context, the preliminary flight acceptance test described in the military standard can be part of a test to be proposed to support first flight. But this should be agreed with EASA. However, these military standard tests are endurance tests only and should be considered valid only to check system transmission and potentially the structural elements which are part of a test specimen definition or representative enough. These tests do not really provide justification for static and durability fatigue. More generally, these tests are not compliance demonstration tests for certification, but they are performed to bring an acceptable confidence level in the design before performing flight test campaign. And considering the interpretation of a test result, we can say that any finding detected during test should be analyzed and corrective action, if found necessary, should be cascaded to the design. We can conclude that the justification, including tests to be performed for first flight and certification, must be accepted by EASA with clear objective and pass-fail criteria addressed in the test plan. The standard test procedure available can, of course, support the compliance demonstration, but are not sufficient to address the certification objective.
Fantastic. Thank you very much. And again, hopefully that answered the question and provided lots of really insightful information. So for the next question, I'm going to turn to my colleague Sasha here with a question about U-Space. We have a question from Marcel who asks, how is U-Space going to solve the tactical conflict detection and resolution, especially when it comes to small UAS, so the kind of quad-rotor, small quadcopter type things in dense urban areas? In the report, published reports and papers, he says he thinks this topic is a bit ambiguous, and he was wondering if there was a more concrete approach so far.
Okay, good, John, thanks. And Marcel, thank you for coming forward with this question. Let me try and shed a bit of light on what you perceive as an ambiguity, and you may have a valid point here. At the outset, let me outline, Marcel, that the U-Space framework with which we will come out now is just the start of everything. So it's an initial enabler, if I may. And more work will come, and this system will be reviewed, will be refined, also in light of technological progress. Now, it is for that reason of technological progress, or the lack thereof, that for now we start with no tactical deconfliction. But the system will initially, the U-Space framework, will initially rely entirely on strategic and pre-tactical deconfliction measures. Why is that the case? Because well, we have a number of DAA, detect and avoid, approaches and systems. However, we do not currently consider as yet those systems to be mature enough or robust enough to really cater for a tactical deconfliction in new space, airspace volumes. So that's something for later to come. And I hope this helped shed a bit of light, as I mentioned initially, to your point, Marcel. Thank you.
Fantastic. And then we have a follow-up question from Peter, who asks, what kind of systems shall helicopters and other aircraft operating in uncontrolled airspace be equipped with to be electronically conspicuous? And then what will be the cost perhaps for this required equipment, and who bears the cost of that equipment? What kind of equipment will drones then carry to be electronically conspicuous to the helicopters? And then how will the UAS be conspicuous to ATC in controlled airspace?
Okay, there is a number of aspects to this. Thank you, Peter, for quite a comprehensive set of questions indeed, and all of those elements are part of our EASA internal discussions, you can bet. Now, EASA won't be prescriptive as regards which technology for detect and avoid is required to be installed in an aircraft. We leave that to industry to come forward and work with standard development organizations. And we have just a task that was kicked off by Eurocae recently on that particular field. So what we intend to provide industry with is minimum technical specifications, but not to prescribe you need to have ADS-B, you need to have, I don't know what other technology there might be for electronic conspicuity. The main point though is we need to have proven interoperability between all those systems, maybe more than one. Most likely will be more than one, because we want to take stock of what is already there, and we also, from a cost perspective, obviously would like to benefit from what is affordable and what is installable in terms of weight and dimensions of those pieces of equipment, in particular to smaller drones. So as I said before, on the previous question, actually, the DAA and its robustness and provenness is probably one of the key enabler for a fully integrated operation of manned and unmanned aircraft in U-space airspace volumes. For now, we don't have that. Work is ongoing. There is an opportunity, though, for industry to team up and to engage in this development, in this work that is ongoing, to the best that they can, in the best of industry's own interest. And with this, I hope, Peter, I have managed to respond to your question.
Thanks very much. Thanks for those answers, Sasha. If we could perhaps turn to my colleague Guillaume now. We have some questions from Lewis. And the first one he asks is, what is the EASA strategy to ensure that data used to train the machine is consistent with all foreseeable operational scenarios? The definition of foreseeable may not be enough to support correct data gathering and avoid covariant shift, and algorithms tend to work better on conditions in which deep NN was trained, and how to define the completeness of the training data versus the completeness of the test data, and how to correlate that data with the system level requirements.
Yes, this is an excellent question. Thank you, John. And I want also to thank Luis for the excellent questions posted on the website. So I have linked actually the answer to this question to another concept or question that was raised by Luis regarding the completeness of the training data sets and the correlation between data sets and system level requirements. So those two questions are bringing us to an essential challenge of defining a learning assurance process. And that is to say the concept of generalization guarantee, which means actually the capability, for example, for a neural network to process adequately and manage adequately inputs that it would not have seen when training. And based on the results that we had from our Codan innovation partnership contract with the company Daedalin, we identified the evaluation of the generalization capabilities of a neural network as a key objective, and as such, as a guarantee that can be provided only by working carefully on the completeness of the data sets. So there is actually whatever the data set we're talking about, whether training, validation, or verification. So there is a direct link actually between those two questions. And I fully agree that with the fact that the coverage of foreseeable conditions as we know them today might not be enough, and we need to push it using the concept, for example, of the definition of the operational design domain. We need to push it one step forward, and that's exactly what we're intending to do with the guidelines we are working on. And there are surely various ways to ensure completeness. For now, we are working and likely to push anticipated means of compliance on the use of a distribution discriminator, as we highlighted in the Codan report, even if this approach may be limited by scalability considerations. So we hope also, and we are convinced, that our applicants will come up with more innovative ideas on this subject in order for us to push the guidelines a bit further.
Fantastic. And then as a follow-up question then, so what is the EASA strategy to open the black box and demonstrate that the expected neurons are behaving as intended? And then the neuron monitoring can provide a clue about the difference between design train data and the requirements test data.
Yes, another very interesting question. So the EASA strategy to open the black box is oriented by two building blocks. The first, the learning assurance I was talking about, that will ensure appropriate visibility at each step of the learning process. And this is what you can see with the description of the W cycle that was explained in the video. The second essential block to open the black box is the explainability of AI, which is the HMI, let's say, the link human-machine, which will put objectives on the capability to provide understandable outputs to the human that is in contact with the AI system. It's important to mention also that EASA guidance will be objective-based. So we won't push someone to deal at the level of a single neuron. I mean, this is something that can pop up as a means, an alternative means of compliance provided, for example, by an applicant as accompanying way to gain the necessary confidence. But obviously, the objective-oriented guidance will not go that deep in the leveling into a neural network.
Fantastic. Thanks very much for those answers. I think they were really useful and interesting. If we go perhaps to another question now for Emily from
Thank
Barbara.
you.
Emily, are you there?
Yes, hello, John, I'm here.
Hi, Emily. So the question we have from Barbara is regards to UAM ID, the MVTA 320 flights over water. And Barbara asks, in point C1, the time threshold is set on 3 minutes. Is there any other time limit below that one? So, i.e., is a life vest needed on board starting from the 3 minutes time of flying on over the water, so that when over the water flight is shorter, it's not required, or could it also be required below the 3 minutes? She thanks you for any clarification you can give on that one.
So the criteria to determine which over water safety equipment will be required for the different operations is currently being discussed, and it's under definition as part of the Air Ops Rules Update of Rulemaking Task 0230. So the criteria given in the presentation for the safety equipment and also for the airworthiness categories are just the current proposals. So they're not finalised, they may be revised. So the current proposal for life jackets is that they will be required for limited overwater operations. So for flights with a total time of more than 3 minutes over water. And also if any overwater segment is longer than the time after critical failure for performance. They're also proposed to be required for any takeoff and landings over water from, for example, floating vertiports. And following our proposed tier approach, of course, if life jackets are necessary for limited overwater operations, they'll also be necessary for emergency flotation and ditching operations. So I hope that provides a little bit more clarity.
Fantastic. Thanks for that, Emily. And perhaps we've got time for one last question for Laurent that comes from Michael. And the question for Laurent is, the opportunity to have catastrophic failure conditions for simply loaded static elements with compensation provisions if the failure is extremely improbable was mentioned. As it was presented in the video, it sounded more acceptable as in the Symposium in 2019. And he said, yeah, it should be the complete exception, case-by-case approval by EASA, just if added complexity or new failure modes can be demonstrated. And Michael asks, did the general guidance and recommendation change since last year? You know, obviously pending the phase 2 mock for structural failure rate.
So first, thanks for the question on the essential structural design requirement applicable to VTOL. It is correct that an alternative to the design criteria no single failure catastrophic has been introduced in the mock for simply static loaded part. But the principle for no catastrophic failure addressed in the 2250C of the VTOL special condition is maintained, still maintained. It is only when all the design solutions have been presented, investigated, and found unpracticable or too complex that EASA can accept demonstration of single failure catastrophic extremely improbable. This is valid or applicable only for the simply static loaded element. This extremely improbable objective or target is achieved with compensating provision, which include additional safety factors, fatigue evaluation, limitation, or manufacturing quality improvement. So eventually, thanks to the mock 2250, we can identify two categories of parts, structural part. The part with single failure not catastrophic, which should include probably rotors element, and as an alternative when demonstrated not practical, the simply static element with extremely improbable catastrophic failure. Thank you.
Fantastic. Thanks for that answer, and thanks to all of our experts for the excellent replies, and thanks particularly also to everybody who took the time to submit questions. We're only sorry that we couldn't answer them all.